Okay, guys, I'm going to get started again. Um, we're going to start learning a little bit about the software that we're going to be using this semester. And I'm going to start with Excel. For many of you, since at least half the class put up their hand that they were familiar with Excel, this is going to be ridiculously simple introduction. But for many of you, this is, I think, going to help you, like understand this a bit better and get a good start on it. If you go to Blackboard, if you have access to Blackboard, you can go into course materials, and then you can go into the folder for this session, session one. And in that folder, you'll see a PowerPoint. The PowerPoint presentation is a PDF file you can download. You'll also see a bunch of files that are in the laboratory portion of this, where you can actually download that, open it from Blackboard in Excel, and that you can work with me on it. Okay, this first one's going to be very simple. The first one is just simply I'm going to blow this up a bit. Number one. Yeah, the one's listed number one. Okay. Um, it's just a basic Excel spreadsheet. When you open a spreadsheet, Excel is just one of many spreadsheet programs. There have been many others in the past. Multiplan, Lotus one. Anybody remember Lotus 123? That was like that owned the market before Excel came along, right? It's hard to believe that that's more or less gone now. VisiCalc, any number of others. Excel kind of has supplanted all of those, just as Word has kind of like supplanted all of those hundreds of word processing programs that used to be available at one time or another. Okay, so the basic thing with Excel is that Excel basically imitates a paper spreadsheet. I'm going to open a document that I have in here. You don't have to necessarily open it also, but I just want to just show you a couple of things here. That's the syllabus. Here we go down here. Let me see if I can open this. Okay, here we go. Blow this up a little bit, make it a little wider, and I'm hoping that you can see that pretty well from back there. Okay, first of all, spreadsheet is a certain kind of program. Spreadsheet is a program that imitates a paper ledger. Years ago, when people used to do this on paper, they used to go to like the what was the equivalent to Staples back in those days, and they used to buy large pieces of papers with columns and rows on it, so that they could put in this column is a debit, this column is a credit, this column represents the stress on the wing, the next column represents the velocity, and the next column represents the thrust, and so on and so forth. It can be anything you want that you use as part of a calculation. At the bottom of it, if it's a financial spreadsheet, at the bottom of it, you might add up all the credits, all the debits, and move that over to the next page, put it up there, and then continue adding stuff to it, and then add it to the bottom and move that total up to the next page, and so on and so forth. Okay. Now, then that's the way people worked on things. When I took, and they used calculators. They didn't have TI 59s and electronic calculators when I took statistics in 1966 or 67. They had this thing, right? This thing was a mechanical calculator. It's motorized. It happens to be electric. They have a little motor in it rather than they used to originally have a crank and stuff like that. But we actually added columns and numbers using these things. Some of the more sophisticated ones would even let you multiply, divide. Some of them even let you do the even statistical versions of them that let you do like sum of squares and that kind of very complicated stuff like that. Nothing like what you can do on a computer now. So we would use these various devices. Now, as I was learning, as I was using this for statistics, the first electronic calculators were starting to show up. Wang Computing produced one that used Nixie tubes. Anybody know what a Nixie tube is? You ever see those tubes? They're about maybe an inch tall, and they got wires in them. And as the number changes, different wires glow. And oh god. Okay. So at any rate, they would have these tubes that are the equivalent of LEDs now. That would show the numbers. And those are the first electronic calculators. First one I ever saw cost about 50 grand. It was at Brooklyn Poly, and we weren't allowed to touch it, of course, because we were lowly students. And we could look at it. Remember, they had those windows with the wires in them and stuff like that, like these institutional windows. We were kind of allowed to look at somebody else working on it, through that wired glass. But we didn't actually get to play with it. I got lucky. I used to have every kind of odd job in the world back in those days because I was trying to raise money for tuition and expenses and stuff. And back in those days, it was possible to actually work and raise tuition. Because as an undergraduate, I think tuition was $12.50 a year when I started at Brooklyn Poly. It's gone up double digits every year since then. It's gotten ridiculous. But so I drove a cab. I worked. I was a good humor man. Not with they wouldn't give me a truck. I had those tricycles and so on and so forth. So I had every kind of job that you would ever think of. But I got lucky. I got a job at New York City Community College. They had open admissions at that time. For a while there, New York City colleges, New York City University system allowed anyone who had a high school diploma or equivalent to go to school. It's called open admission. Now, if they were deficient in some subject area, they had to take remedial courses. It was free. The only thing you paid is a fee. You didn't pay by credit, right? So it was a great place to learn, New York City back in those days. But they needed a lot of people to help people with remedial math. So they hired some students from Brooklyn Poly that were good math, and we would work in a lab, like a language lab, have like boards on the side, and you have an area to work that's pretty private and quiet. And then have rooms with 100 of these little tiny cubicles, and we would just kind of circulate around. Somebody had a problem with their homework, they would try and they'd raise their hand, and we get a chance to go over here and help them with it. And they would use these kind of calculators. I taught literally 300 people how to use a slide rule. Anybody ever seen a slide rule in this room? You've heard of them, right? Right. The slide rule is a device that you can use. You see it in, like the old NASA films, from the, space program and stuff like that. It's a calculating device with a couple of number scales with a stick, and you move them around. And one of these days, I'll bring one in and show it to you. So we would use those kind of things. By the time I got out of college, all of these were obsolete. Between those 4 years, right, that I started, taught people how to use the slide rule, how to use this stuff, that I started college, and the time I got out of college, or finished that portion of college anyway, um, Texas Instrument had come out with a device that basically buried all these devices, right? So they were literally completely obsolete. And everybody was using electronic calculators by that time. Not quite what you see nowadays. They were a lot simpler: multiply, divide, not too many extra things. Okay, so now this is what a spreadsheet looked like, right? Here's a car loan. They have an amount, interest. That's the interest, number of payments, 60, monthly payment, calculation, and so on and so forth. The spreadsheet on a computer, as you know, looks more like this. But that's why they call it a spreadsheet. It's emulating something that looks like a spreadsheet. First spreadsheet on microcomputers, which is where this stuff really took off, was called VisiCalc. I'm going to play a video for you. I don't know if this will actually record. I'm going to turn off the recording for some recording. Okay, so for starters, that's what a spreadsheet looks like. You can't see the grid, the line so well up there right now. But basically, it's organized into cells, these little boxes that you see here, right? You can download this on your computers if you want to from Blackboard, if you want to follow along. But each one of these cells is identified by a column and a row. So this is right now I'm in cell B4, C5, and so on and so forth. D13. There actually at one time when they first came out, there were limits to these things. There's almost no limit. The only limit is the memory in the machine at this stage for these various spreadsheets nowadays. Okay, so now you can put whatever you want into these cells, but there are three basic categories that it recognizes. One category is called the label. For instance, January, just text. February, right? Kind of our nominal data that goes into those things. You can also put into any of these cells a number. 100, for instance, hit enter. Notice it right justifies when you put a number in. You can put in a number with a decimal point, right? Any kind of number you want into one of these cells. The third thing that you can put into these cells is a function, a mathematical function. For instance, in this cell, I can put in, say, the sum of two other cells. And I let it know that I'm going to put a function in here by hitting the equal key. The minute I hit the equal key, I'm going to do that again. If you keep an eye up here in this area up here, when I hit that equal key, it changes. That fades away, and I get a little symbol here, and I get an equal sign echoed up here. And I can say, well, I want to add 100 plus 200. And simply, I can put that in there, and it'll do the addition for me. Instead of that, I can also Notice that I can edit it from up here. You see the whole formula there. I can also put an equal sign in there and say that this is equal to a value in another cell. It's equal to this number. When I hit enter, it's going to put that number in there. If I change that number, it'll change the other cell as well. Okay. I can put complex functions in here. Equals 100 plus 117. Notice I don't actually have to put the numbers in. I can just reference the other cells. And let's say minus this cell, that comes out to 100. Okay, so I can build functions in here. In addition to that, it gives me a library of other functions. If I go up here, this little symbol f of x, which in math means function of x. If I click on that, I get a list of all the different functions that are available in this particular version of Excel. You see in the beginning, you see the ones that I've used most recently. It happens that they're statistical because that's what I've been using it for. But there's database functions, there's time functions, there's math functions, there's geometric functions, financial functions, you name it. There's hundreds of functions that are available here. I'm going to just employ a couple of them right over here. Let me hit escape. Forget about this. I'm going to go over to this portion of the spreadsheet. And I'm going to say, okay, here's a order list with prices. Somebody ordered 10 of a particular device at $11.20 each. So what's that going to cost? It's going to be equal to what's in this cell times, use asterisk for times, what's in this cell, the cost. Okay, $112. I'm going to do it again for the next cell. It's going to be equal to what's in this cell times what's in this cell. Well, that gets pretty tedious after a while. If you can imagine, I have a long list of numbers. Wouldn't it be advantageous to me if I could copy that function into the other cells without having to bother with the individually calculating each one of these? Well, if I click on this first cell and drag down, just like that, I've highlighted the first cell and the others that I want to copy that function into. I'm going to go up here to edit. I'm going to go to fill. I'm going to say fill down. Okay, there's other ways to do this. It's blocked out for me. There's functions in this bar where I can do the same thing. In Excel, here it is on the Mac version. It's here. I can fill down. Same thing as going into edit and saying fill down. On the PC, usually you see it on the right-hand side of what Microsoft calls the ribbon. You know, for your home ribbon in Excel. But I'm gonna click here on edit and fill down. And when I say that, it takes that formula in the first column and it copies it down. But it sees that it's next to two other columns. And it intelligently says, well, Tony wanted to multiply 10 times 11.2 and put it here. So when he's filling this formula down, he must mean he wants to multiply 20 times 20, and then 10 times 14, and then 40 times 14. And in fact, if you click in here, you'll see that this first one is F3 times G3. The next one is F4 times C4, and F5 times G5, and so on and so forth. Saves me a lot of work and a lot of trouble. There's many functions in Excel that work this way. Down here, I'm going to use a completely different function. I'm going to put the equal sign in here, and I'm going to dig out one of the functions that's in this list, sum. I'm going to click on sum, and it tells me it adds all of the numbers in a range of cells, right? So it took the sum of all of those numbers that are up above it and added them all together for me. This is the power of an Excel. Remember I told you they would add up columns of numbers, transfer to the next page, add up columns of numbers, transfer to the next page. If they made a mistake on page one, they'd have to recreate everything before. In Excel, if I make a change, oh, this guy only wanted 19 of these things, not 20. It updates all the other cells that are based on. That's the real power. The functions and that capability of being able to make changes on the fly and how to recalculate everything yourself are the real power of these spreadsheet programs. We're going to be using mostly statistical functions in Excel, but you can imagine this has an immense number of different applications. I'm going to open up the next version of this next thing they have on there. It's a budget demo. Okay, I'm going to say 200%. Okay, so here's our budgets, our credits. This is how much money we make. This is what our expenses are. So our total debits is equal to our sum of all of the stuff that's in these columns. Now I could type in B4 colon B9 and have it give me the total, but it also allows me just click in there and scroll down while I'm holding down the mouse key and tell it that that's the range in numbers, right? That's a lot better than, like saying, I could have just typed in B4 to B9 instead. You can see what is represented there up there. Okay, now I'm going to take a look at what my how much I'm making equals the sum parentheses. I'm going to click into the first cell. It fills in E form for me, and then pull it down, and I'm down to E6. And I'm making $1,400, and I'm spending $1,740 a month. I got a problem there. So the balance is equal to 1,400 minus my 1,740. I'm in the red, $340. I got to start saving some money. Right? So what am I going to do? Let's see. We'll cut back on the entertainment budget there. All right. Let's go down. Let's change that to 300. I'm still south 140 bucks. Tuition, I can't change that. Transportation, can't change that. Well, let's get a roommate. Okay. Split our rent here, $240. And now we're $110 positive. I can put money away for retirement. Okay. So again, a what if kind of situation. We can use this software for so many different applications. I'm going to pull up another one, the budget demo. Now, the other thing that we can use this software for is that we can use it to help us display information graphically. Displaying information graphically is an immensely important tool. Okay, and in this particular situation, this is kind of a environmental health example. I have locations that I've tested with something called mold spore traps. They're little devices, little canisters that you suck air through at 15 liters per minute. And what they do is they have a little sticky surface, a little glass with a sticky surface on it. And if there's mold spores in the air, they get stuck on that little sticky surface. The canister goes out to a lab after you've sampled, say, 150 liters of air. A microbiologist actually goes through and actually counts the number of mold spores and attempts to identify them. Okay, so now we're looking at a couple of outdoor samples and the total mold spore counts. We're looking at an area where there were some complaints, these 4 samples right there, and an area where there weren't many complaints. I can look at the numbers and see, oh, the numbers are higher outdoors, but it's kind of hard to interpret this and stuff, and so on and so forth. Let's do this another way. I'm going to highlight this whole thing, and I want to display this information graphically. So if you notice in the ribbon here, we have an area we can go to that's called charts. Okay, and in charts, I can pick out a column graph, a bar graph or a column graph. I'm going to pick out columns. It automatically, because of the way that the information is laid out, it automatically creates a chart for me. I can take this chart, copy it, paste it into a Word document, use it as part of a report. Literally took me a split second to produce that graph. I could go in now and edit this graph if I want to change things. I want to change the color, the text size, and so on and so forth. I'll give you another example of that. Here's another version of it. Let me get rid of that. Here's another version of it where we're looking at some public health information. We sample a population, and we find that in that population we sample a total of, how many people were in this sample? Let's see, I can take the sum of this and get the total. 178 people were in this population. Notice that these numbers are centered. That's because I can always highlight any of these, and I can change the alignment. If you look at that ribbon at the top, you can change font sizes, bolding, color, and so on and so forth. You have a lot of flexibility over that. So now I want to display this in a way that's a little bit more intuitive. Where are most of these people anyway? Are they uninsured and so on and so forth? I'm going to highlight this whole thing. And maybe this time I want to do a pie chart, right? Because pie chart gives you kind of a good way to interpret, percentages and so on. So I'm going to go in here to pie, simple pie chart. And there we go. In moments, we created a pie chart from a list of a couple of numbers. Okay, isn't it easier to see what's going on here? I mean, this big green area, that's the bulk of our patients. They're mostly on Medicare, right? And this is more than 50% of our patients are on either Medicare or Medicaid, right? So we can very easily see some important information. It's very, uh, 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 it's really much more intuitive when we display it graphically. We're gonna learn how to display a lot of statistical information graphically, and we're also gonna learn how to summarize data so that we can organize and understand big piles of numbers in a lot more efficient way than just looking at stacks of numbers. Okay, so now let's see. Let's go on to the next one here. Save. Go up to number 4. Okay, let's take a look at this one now. Now, this one is a good one if you really want to give this a try, to download and maybe do on your own. Now, I am recording this, so you can always go back and download this at home and play through it and so on and so forth. So now, I'm getting a little ahead of myself here, but this is something we're going to cover more next week. But what am I interested in when I take a sample of a population? If I take a sample of a population, I'm interested. Remember, I mentioned that, like, well, the data tends to accumulate in the middle, right? So if I took everybody's height, all the Hunter grad students' heights, I'm going to get most of the people are going to be, I don't know, between 5 feet tall and 6'5" tall. There are going to be some people that are shorter, some people that are taller, but the further I get away from the middle, the fewer and fewer people I'm going to find that are that height. So there's a tendency, a central tendency for most numerical data that's randomly distributed. Okay, so now that central tendency is something I'm interested in. What's the average height of all Hunter students? Well, I don't know about all Hunter students, but I took a random sample of 10 Hunter students. Let me see. 80, is that a root of 5? That's not a height. What can I call that? I'm going to call that their grades. Yeah, we'll call it a grade. What average did they? Now, this is a standardized test that all Hunter grad students took. I randomly sampled 10 students, and this is the distribution that I got. This is the results that I got. Well, let's look at what the average is for this. Well, there's a couple ways I can figure the average. First thing I can do is I can add these together. Right, there's 10 students equals the sum of all of these numbers. Okay. Let me just make sure. Let me see if I can blow this up a little bit more. Yep. Okay, that's the sum of all of those numbers, 825. How many students are there? There's 10, right? So I can say the total number of students is 10. Okay, I can look at that just by examination, right? So the average is going to be equal to 825 divided by 10. Cell C4 divided by cell C5, or 82.5 is my average. As it happens, Excel has a number of statistical functions built into it, okay, including mean. I'm going to go up here. I'm going to go up here to function of X and pull that up. And gee, average. I don't have mean, but I have average. Average is the same thing, right? So I'm going to use average instead. Instead of picking it off from here like I did the last time, I'm going to click in here and I'm going to actually type in =, average. And as I complete it and put in the parentheses, it gives me a little prompt asking me, well, where are the numbers that you want to average? You got to put those in now. So I'm going to click on the first number, drag down, and tell it I want to average numbers in cell A1 through A10, and it gives me the same number. We have much more complicated functions that are involved. Now, what's median? Anybody know what the median is? The middle value, right? Average is the arithmetical average. The median is the middle value. So let's see what we have here. I'm going to type in = median, parentheses, and sure enough, there's a function for median as well. I'm going to highlight all these, and it gives me the middle value, okay, which is 80. Okay, and if I wanted to really check it, I could take this, copy it, and paste it over here. Except now I can go up to data and say sort the highlighted part of this data. Okay, and say okay. Now they're in order, right? Did you see that change? 70, 75, 80. I sorted this column of numbers. The middle value, well, 10 numbers, there is no middle value, right? There's 80 and 80. The fifth value is 80. The sixth value is 80. So in that case, the median is the average of those two numbers. They're both 80, so the median, in fact, is 80. This is we calculated it before. How about the mode? What is the mode? It's the most common value, right? In this case, I sorted them, so what's the most common value? 80 again. Let's see if that works here. Equals mode, parentheses, okay? And I'm gonna tell it that these are the numbers I wanna find the mode for, and sure enough, it's 80 again, okay? You also have functions for maximum and minimum. Minimum, parentheses, and I can just go through this number. Now imagine instead of 10 numbers, this is 100 numbers, right? It's a little bit difficult to go searching through all this for the smallest number, biggest number, and so on. So these functions actually get practical. Max, parentheses, to be the maximum number. And the range is just the difference between the maximum number and the minimum number, right? The range of values is 25. These are our first statistical functions that we've calculated. This is our first sample. Next week, we're really going to get into this a bit more. I mean, next week. I'd say reflexively say next week. Next week is 2 days from now for us. Right? That's the way the summer session is. I'm going to close this, get it out of our way. Okay, I'm going to take a look at this. Okay, now 4, that's statistical function. This spreadsheet is for calculation of black body radiation at different wavelengths and temperatures. Right? Where anybody know where we might be interested in black body calculations? Think of a very large object that normally is radiating energy into space that now, because something's happened, is not able to radiate that energy away as efficiently as before. Black body in space, glowing, blue ball, like bluish, right? The Earth. That's an important calculation in terms of global warming. The reason why our Earth is warming is because normally we'd be a black body in space getting rid of energy at a certain rate, but now we have this cloud of carbon dioxide over us that is reflecting that energy back, causing a greenhouse effect. These are some of the calculations we might use in that. This spreadsheet literally you can put numbers in and calculate the rate of a body like the Earth um, uh, 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 getting rid of heat over time. No, I'm just showing you this because I want to show you there's other applications for this. Here's one. That's a mortgage calculator. You getting ready to buy a condo? There's a spreadsheet, and you'll find these. If you Google Excel spreadsheets, you'll find every imaginable kind of spreadsheet, every imaginable function. This particular one is one for calculating what your monthly payment's going to be, different interest rates, different loan amounts, different terms, and so on and so forth. And I lost my, here it is up here, right? So you'd actually be able to use that. I'll upload this in case you're interested in it. And if you want something a little bit more frivolous, if you're trying to keep track of your fantasy baseball league, you got baseball statistics worksheets, right? Most people that I know that play around seriously with any kind of you know fantasy league, if they're really serious about it, they got their own calculations that they're doing, and they're working with Excel and stuff like that. So there's just an enormous number of applications for spreadsheet programs. So even beyond statistics, it's worth your time to really learn some of the things that you might want to do on this. We're not likely to be able to get involved in this. I'm going to demonstrate it at some point during the semester. This is a problem involving age adjustment. Now, these are actual mortality rates for different age groups in the city of New York in the year 2004. Okay, so there were a total of, these are deaths due to cardiovascular disease, I believe. There were a total of 12,650 females that died due to cardiovascular disease in New York City, right? And the crude rate of death due to cardiovascular disease was 12,650 out of a population of 4,214,000. Or see, that's I don't see anything there because it's formatted for only one decimal place. I could go in and format it for more decimal places. Format cells. Okay, show me not just one decimal place, show me 4 decimal places. Oh, there it is. There's the rate there. In fact, I can say, I can also put this in these terms. I'm going to multiply that number times 100,000. And the rate of mortality for females in New York City is 300.18 per 100,000. I'm going to do the same thing for males. These are actual numbers. Equals sum, parentheses, oops, that helps if you spell it right. Okay, does not, and that's equal to that number of males dying out of that population. I think I'm not going to bother with it there. I'm just going to take it and multiply it by 100,000, so we get it per rate per 100,000. Okay. Females die of cardiovascular disease at the rate of 300 per 100,000. Males die at the rate of 262 per 100,000. I just discovered something. Females are more susceptible to heart disease than males are. Does that make any sense? Does it? It doesn't, does it? We know guys like me, we're heart attack, home, like we're home for heart attacks, Guys in their 50s, 40s, 50s, 60s, 70s, and so on and so forth get most of the heart attacks in this country. So why does it look like it's a bigger problem for females than for males? That you're more at risk for a heart attack if you're a female than a male. Bingo, the population. What about the population? If you notice here, how many females, one of the risk factors for heart disease is age, right? How many females over 85 are there? 87,000. How many males over 85? 34,000. So the population distribution is much different. There is a much larger population of older females in New York than older males. That's skewing the information. So these rates are not really representative because the populations are different. You're taking a relatively young population and comparing it to a relatively older population. So we need to correct for that. That's something called age adjustment or standardization. It takes place all the time in statistics. It needs to, because a lot of times you see these differences and the differences aren't real. They're only there because the populations are different. More smokers in this group than another group. They're confounders. Older population, younger population. I'm going to work through an example of this later on in the semester, but this is something that we'll be using Excel to do. Okay, so that's age adjustment. You're not going to be required to do this. It says this is 751. We make you do these yourself. But you'll see me do it. You'll understand how it's done and stuff like that. But you'll see when I do this adjustment, it'll correct for age, and males will be at greater risk for heart disease. These numbers will flip, in fact. But we'll get into that later on in the semester. I just want to prepare you for what that is. So we're still kind of in the orientation stage of this whole thing. Okay, so now I want to show you another video because I think it's really important that you really grasp how important graphics is and how useful a tool it is for understanding statistics and communicating statistics. And I would love to see you using it when you do that project at the end of the semester. That I would love to encourage you to use it. I'm gonna stop recording for a second.